You now have everything you need to make huge progress with Arduino. You have seen how to create a basic circuit, how to create a basic program with programming fundamentals, and how to upload this program to your Arduino board. Now the fun part begins. In the following sections, you will discover how to use standard components like LED, push button, and potentiometer using the Arduino pins. And later on, we will dive into more advanced functionalities and sensors in order to build a complete project. So right now, let's come back to the LED. You already have a circuit with an LED and you have created a program to make the LED blink. It's time for you to understand how this really works and what you can do with it. To be able to fully control an LED, you need first to understand how to use digital pins on Arduino. So on the Arduino board, you have two kinds of pins to control hardware components: digital pins here in orange and analog pins in green. In this section, we are going to focus only on digital pins, and we will see analog pins after that. On the Arduino Uno, you have 14 digital pins. As you can see here, the pins are represented by a number from 0 to 13. On different Arduino boards like Arduino Nano or Mega, you may have a different layout for the pins or even a different amount of digital pins. But if you understand how digital pins are working with this Arduino Uno example, then it will be very easy for you to work with any other Arduino board. So a digital pin can be used either to actuate a component, such as an LED like we did before, or to read from a sensor, for example, a push button. Now, how to work with digital pins? Well, the first thing you need to do is to set a mode for the pin. You can choose either input or output mode. In this lesson, because we are working with an LED, we will only focus on the output mode. And then, once the pin is set as an output pin, you can change its state. For that, you have two options, high or low. This is a binary state. High means that the output will be 5 volt, because that is what the Arduino delivers, and 0 means 0 volt. So if you put an LED on a digital pin and set the pin state to high, the LED will be powered on. Then if you set the state to low, the LED will simply be powered off. And now that you have a better understanding of digital pins as output pins, let's quickly make a recap of how to work with an LED. So here in our circuit, we already have the LED plugged on pin number 12. So the first thing I'm going to do is to do a define with LED pin 12. So I'm going to create a constant here with define LED pin all uppercase with an underscore, and then directly the value. So whenever we need to use this number in our code, okay, for the LED pin, we just need to write LED pin instead, which will make it much easier later on if, for example, we want to change the pin where the LED is attached. So first step, you use a define to easily get access to the pin number in your code. And then in the setup, so I'm going to remove that comment. In the setup, you will use the pin mode function here to set the mode of the pin. So for now, we have seen only the mode output. So the first parameter here is the pin number and then the mode. So the mode will be output, all uppercase, and it should turn blue, okay? Once you have done that, the pin 12 is defined as an output pin, okay, not an input pin. So from now on, after you have used the pin mode function, you can change the state of the pin. And we can directly do that here if we want to. Digital write LED pin with, let's say, high, because it will be low by default. So we set the mode, and once we have set the mode, we can directly set the state, whether high or low. So now let's say in our program, we want to make the LED blink, but first When we start the program, we want the LED to be powered on for 3 seconds. So for example, we can do delay 3000 here. So we power on the LED, we wait for 3 seconds, and then we will enter the loop function. Okay, and in the loop function, well, digital right LED pin. So here maybe we are going to start with low, and then wait for, let's say, 500 milliseconds, and then digital right LED pin high, wait for another 500 milliseconds. All right, and we have our blink example right here. So nothing complicated, as you can see. First, we set the mode, and once the mode is set, we can just change the state as many times as we want. So now let's upload this program here. Name it LED. All right, and you should see the LED powered on for 3 seconds, and now the LED is blinking. Let's come back to our digital pins on the Arduino Uno. As you can see, some of the pins have a PWM function. I'm going to explain what is PWM just in a moment. So you can recognize them with the tilde near the number for the pin. On Arduino Uno, out of the 14 digital pins, 6 of them can be used as output pins with a PWM. They are pins number 3, 5, 6, 9, 10, and 11. Now, what is a PWM? PWM means pulse width modulation. That's quite a complicated name, but you will see it's quite easy to understand. When you use a digital pin with a binary state, either the voltage is high, which means 5 volt all the time, or low, which means 0 volt all the time. With a PWM, you can choose to make the signal high only for a fraction of the time, and this fraction of the time in percentage is called the duty cycle. So here we have 3 examples. First, with a duty cycle of 0%. This means that the signal will be high 0% of the time. Thus, the signal is always low. In practice, this is the exact same as just using digital right with low. If we look at the third example on the bottom, here we have a duty cycle of 100%. That means that the signal will be high 100% of the time. Thus, the signal is always high. In practice, this is the exact same as just using digital right with high. And now the interesting part. If you look at the example in the middle, you can see we have a duty cycle of 25%. This means that the signal will be high 25% of the time and low 75% of the time. In practice, for example, when you power on an LED using the PWM of a digital pin, well, if you set 25% of the duty cycle, it's very similar as if instead of supplying 5 volts to the pin, you just supplied 1.25 volt, which corresponds to 25% of 5 volt. Thus, you can expect the LED to be powered on, but with a lower intensity. To make it simple, just think about the duty cycle of the PWM as a percentage of the total voltage. And you can see that if you modify the PWM duty cycle between 0 and 100%, you can have much more control over the average voltage you supply to your components. Now, on the Arduino, the percentage will be represented by an integer number between 0 and 255. 0 is of course 0%, and 255 is 100%. If you want to apply a 25% duty cycle for the PWM, you will then need to give 25% of 255, which is about 64. So let's complete our diagram. We are still setting the mode for the digital pin as output, and then we have 2 options. Either we use the pin with a binary state, which means we use the digital right function with high or low, or, and this only applies to pins with the PWM mark, we can set an analog value using the analog write function, which we are going to see in the next lesson, and provide a value between 0 and 255, which corresponds to the percentage of the duty cycle. Let's now see how to actually use the digital pins with a PWM function on the Arduino. And we are going to use the analog write function that I'm going to explain to you in just a minute. But first, we need to change something in our circuit. Why is that? So we have our LED, which is correctly plugged to the Arduino, but if you look at the pin here, we have plugged the LED to pin number 12. Okay, and the PWM function is only available here when you see the tilde, okay? So for example, pin number 11, 10, 9 here would do, but not pin number 12. So if you want to be able to use the analog write function for this LED, okay, to provide a PWM, you need to change the pin. So what I'm going to do is simply, so I click on the wire here and there is this dot that I'm going to change here to pin number 11. All right, nothing else to change, okay, we just changed the digital pin for the LED and now the LED is connected to a pin that has the PWM function, so we can start to write the code. And how to change the pin on the real Arduino? Well, it's quite simple. So first make sure that you have unplugged your Arduino board. And then you simply, so you don't change anything, you simply unplug here this wire, which is on pin number 12, and you just put it on pin number 11 right here. Okay, and that's it. And now back to the Arduino IDE. So if you want, you can also do that directly on Tinkercad. So back to the IDE, and you can plug the Arduino board to your computer and make sure you have the correct board and the correct port here. And let's see how to use this analog write function. So I'm going to remove here the comments. And first, as usual, I'm going to use a define, okay, for the LED pin. So this time it's not 12, this time it's 11. Now in the setup function, what I need to do is pin mode LED pin output. Okay, so to initialize the pin, okay, to set the mode for the pin, as you could see in the diagram in the previous lesson, we still need to set the pin to output mode, okay? Whether you use digital write or analog write, you still need to set the mode as output. So now the pin has been initialized in the setup function. Let's directly use the analog. So analog write, okay, you can see it turns orange like this. So analog and then uppercase W. I open the parentheses. Here I need to provide first the pin number, LED pin, just like we did in digital write. And then in digital write, we directly set high or low state. But with analog write, we are going to provide a number, so an integer number, between 0 and 255. So let's test, let's say 20. So I close the parentheses and don't forget the semicolon. So here the program will simply initialize the LED and set an analog value, so a PWM with a duty cycle, okay, which is 20 out of 255, which is a little bit less than 10%. Okay, and let's actually compile and upload the code. I'm going to name it analog write. And as you can see, the LED is powered on, but the intensity is quite low, okay? Now let's test with 200, which corresponds to about 78% of the PWM. So the intensity here should be much stronger. So let's try that. All right, and as you can see, your LED now is powered on again, but with a higher intensity. So you can try all kinds of value, okay, between 0 and 255 to see how the brightness changes with different values. And now let's try the two special values, which are 0. So 0 means 0%. So if you send analog write with 0, the LED will simply be powered off. And with 255, the LED will be powered on with the 5 volt, okay, which is just what you would do with digital write and high state. All right, so as you can see, analog write function is not that complicated. Make sure first that the pin you try to use with analog write has a PWM function, otherwise it won't work. It's time for a new activity. In this activity, you will practice with the LED, with the PWM function, and also with the programming concepts you have seen before. So open a new project here, and your challenge will be to make the LED fade in and fade out, just as you can see on the video right now. So how to do this? I'm going to give you a few hints, okay, and then the solution in the next video. So first you will need to initialize the LED like we did before with pin mode and etc. And then to make the LED fade in and fade out, you will actually write code in the loop, okay? And you will need to use 2 for loops, okay? So for loop here to go from 0 to 255, and another for loop to go from 255 to 0. So why is that? Because the analog write function can take a value between 0 and 255. Okay, 0 means powered off, and 255 means powered on with the maximum intensity. So you need to go from 0 all the way up to 255. And then once you reach this number, you need to go back to 0, okay, step by step, number by number. And every time you will put this number into the analog write function. So you will have analog write with 0, and then with 1, with 2, with 3, etc. But as you can guess, you are not going to write the analog write function 500 times, okay? Instead, you are going to use for loops. So you have already seen how to use a for loop to go from a number to another number by incrementing the index every time with I++, so that you know. But actually, it's not the only way to write a for loop. You can write a for loop to actually decrease the index, okay? I'm just going to give you the structure for that. So you will have your for loop, and then you start the index. Instead of starting at 0, you will start at 255, okay? Semicolon. And then the condition so that the loop can continue is simply that the index is greater or equal than 0. And finally, what we're going to do with the index is not I++, but I minus minus. Okay, I++ means you add 1 to I minus minus means you decrease I by 1. So we start 255 and then 254, etc., all the way down to 0 and then stop. All right, so with that, you should have enough information to do the activity. And also what you're going to need, the last thing is to add a small delay, okay, between each analog write that you do, because if you do it at full speed, it will be way too quick for you to see anything. So you can add a delay of 5 milliseconds, okay? Between each iteration of the for loop, you can add a 5 millisecond delay. This is the value that I used in the video that I showed you about the result. Now, of course, you can tinker this value if you want to increase or decrease it. It's up to you. And now, well, it's your turn to practice, and I will see you in the next video for the solution. This is the solution of the previous activity where you have to make the LED fade in and fade out. So we can actually separate this project into 2 parts. First, we need to make sure that we have the index going from 0 to 255 and then 255 to 0. And then we need to set up the LED and use the analog right function. So I'm going to work first on the 2 for loops we need to do. Okay, and make sure we have the correct values using the serial monitor for debugging. And then I'm going to write the analog right function. So I'm going to remove all of the comments. Okay, and start with the first for loop. So for, and then we create, of course, an index int I is equal to 0. So we start at 0. And then what is the maximum value we want? The maximum value we want is 255. So I is lower or equal than 255. We could also use I is strictly lower than 256. And then I plus plus. So the for loop, we go from 0 to 255, increasing by 1 every time. Okay, that is the first for loop. The second for loop, so I'm going to put here space. We are going to start from 255, okay, and we are going to stop at 0. So while I is still greater or equal than 0, we continue, okay? You can read this as while this is true, we continue. And then I minus minus, which means that we are going to decrement this index every time. Okay, and now the for loops are complete because here you can see we start at 0, we go to 255, okay, in this one, and then from 255 to 0, okay, and once we have finished those 2 for loops, well, we go out of the void loop and we go in again, and we start again at 0. So there is a continuity with the index here. And now what I'm going to do is simply print to be sure that we have the correct values. So serial.begin, okay, don't forget that, with 9600 baud rate in the setup function. And here I'm going to do serial.println with I, and also serial.println with I as well. And as you can see here, we use the same name I because this is a different scope, okay? Here, the I variable is local to the for loop. So basically, it is contained between those 2 curly brackets, okay, in this scope. And this I is in that scope, okay? So 2 different scopes. And now what I'm going to do, I'm going to add here delay 5, okay? I'm going to add the delay, because if we don't add the delay, it will print very, very fast, and it's not that readable. And well, let's try this first part. So I'm going to compile the code as activity 2. Okay, let's see if we have any error. No, done compiling. So now tools, board, and ports are correct. Actually, well, just for printing, I'm going to increase this delay a little bit because that's going to be a little bit too fast just for us to read the value. So a delay of 50 milliseconds will be good. I'm going to upload the code now. Loading, I'm going to open serial monitor, and you can see we go from 0, okay, it's increasing. So 150, 200, and then 200, you will see here 255, and then we decrease the value, okay? So 100 here, we go down, and we are approaching 0, and you will see here 0, and then we go up again. So now we are sure that the index here, the I value that we need for analog write, has the correct behavior. Okay, so what we can do now is actually to set up the LED. So define LED pin 11. In the setup function, we are going to do pin mode with LED pin and output. And in the void now, instead of printing here, so we can remove that. Actually, I'm going to comment it. instead of printing I, we can directly do analog write with LED pin and the value I, which we know is going from 0 to 255 here. I'm going to put back the delay to 5 milliseconds. And then on the other for loop, analog write LED pin I as well. Okay, this is the same code, but here the I is going from 255 to 0, and also the delay 5. And let's run that code. So now we don't check the side monitor, we check directly the LED. And as you can see, the LED is fading in and fading out, just like we wanted. So as you could see on this program, sometimes it's easier to break the program, break the project into different steps and try to validate each step one by one, okay? Once you validate one step, like we did here with the index, we can go to the next step. And this way, creating projects will be much easier for you and you will make much less errors. All right, congratulations, you have just finished this activity, and now we are going to look at digital pins as input pins.